Hey guys, this is Sajil with Ivy Admissions, and this is our difficult questions series for the SAT. So we have this question here. In the xy plane above, O is the center of the circle, and the measure of angle AOB is pi over a radians. What is the value of A? So you can pause the video here and find the solution on your own, and then we will discuss some possible ways to tackle this problem. So anytime we see a question like this, usually these difficult questions on the SAT expect you to utilize different pieces of knowledge that you have accumulated throughout your mathematics career. But the first thing we want to do is figure out what exactly is this question asking. So in this case, it's asking, what is the value of A? And this A is in reference to this pi over a radians angle that we do not really know yet. So usually when we have an unknown angle and we have corresponding sides of a triangle that we can use to rationalize that angle, we usually use these common culprits, sine, cosine, and tangent. But you might be wondering, where is the triangle in this example? Well, in this circle, we can create this triangle, interior triangle from AOB, and if we recreate that here, we'll realize that actually the SAT gives us just enough information to find the side lengths of this internal triangle. So it gives us this y-coordinate of 1. So we know that this height is actually in correspondence to 1, and that this width, or this x-coordinate, is in correspondence to the width of this triangle here. So now that we know this, and we know that we're looking for this internal angle, we can reference our trusty SOHCAHTOA. So here SOHCAHTOA tells us that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So we can assess this angle that we have here and realize that in reference to this angle, we have this opposite side of 1, and we have this adjacent side of radical 3. So the only trigonometric value that is in correspondence to those two sides is tangent. And we know that tangent is equal to opposite over adjacent. So in this case, tangent of this angle here, we're just going to say it's angle O, is equal to the opposite side, 1, over the adjacent side, radical 3. And we never want to have radical 3 or square root of 3 in the denominator. So we're going to multiply this by radical 3 over radical 3 just to simplify it. So we end up getting radical 3 over 3 as the tangent value for this angle. So now what do we really do? The SAT actually would expect you to find this hypotenuse as well. So this hypotenuse ends up actually being 2. You can find this using the Pythagorean theorem. You can find this using the distance formula between this origin and then this point. And once you have that, you'd also be able to find that the sine of this angle is equal to 1 over 2. And you can also find the cosine as well. But now that you have these values, what can you really do? Ideally, you would have memorized this entire table. And this entire table is something that is a little too much information to memorize, but if you do know it, you can kind of see this first tangent that we found, radical 3 over 3, corresponds to an angle of 30. And if you found the hypotenuse from earlier, you can also do it from sine. Maybe you remember that sine, when it's equal to 1/2, means that the angle is 30, and maybe you don't. So what do we do now that we know that this angle is 30? We want to convert this angle 30 into radians. What we do know is that 360 degrees is equal to 2 pi radians. So basically we know that 30 over 360 is equal to this x value over 2 pi. So what do? We multiply 2 pi times 30 over 360, have that equal to x. We just cross multiplied here. And simplifying this, we end up getting x is equal to 2 pi over 12, which is equal to pi over 6. And again, we're looking for this a value, which is in correspondence to pi over a. So this angle is equal to pi over a, and we can kind of see here a is equal to 6. So we went through all this work and had to memorize this entire table just to finally get to the answer of a equals 6. There's actually a calculator solution that you can follow too, but this is a no calculator problem, open answer problem on the SAT. So let's try to think of some easier ways to solve this problem without having to memorize that entire table. One thing that you always want to keep in mind when you see a triangle like this on the SAT, or you see something that you might be familiar with, is you want to pay attention to if it falls under a given formula that the SAT gives you. So at the beginning of any SAT math section, whether it's calculator or no calculator, they give you these formulas. So these are pretty simple. They have a circle here, you have the area of a rectangle next to it, but these special right triangles are what we need to focus on. So if you look at these special right triangles, you have two, and this 30, 60, 90 triangle is what we really want to keep in mind for this question, because if we notice from the triangle that we created earlier, we had a side length of 1 and side length of radical 3. That is in exact correspondence to these values here. This 1 is equal to x, and this radical 3 is equal to x times radical 3. And once we can identify that these side lengths exist, we'll know immediately that this is a 30, 60, 90 triangle. And we can just, for the sake of completion, figure out that this side is 2 times x, and we know that x is 1 is 2. Once we have this in mind, we don't have to use any trigonometry at all. We immediately know that the angle is 30, and once we know that the angle is 30, we can create this relation here to find out what angle O or angle AOB really is. And like we worked out above, angle AOB ends up being pi over 6, which is equal to pi over A, which is what we're looking for. And we'll figure out that A is 6 without having to memorize any tables, without even having to use any trigonometry at all. As long as we pay attention to when these forms, 30, 60, 90, or 45, 45, 90,